Hi, everyone, and thank you for joining us.
Hi, this is the state. This is wave hello, everybody. There we go.
Amazing. Right. Well, thank you, everyone, for joining us today. This is Building the Future with Alan Tsui, and this is an Hour of Code event because we all know that it is Hour of Code / CS Education Week this week, which is why we're all here. So, quick introductions. I'm Nat Ratner. I'm the marketing director for Robotical. I'm being joined by Sarah Walker, who's the UK partnership manager for Strawbees, and Alan Tsui, who's the subject lead for primary computing for Willowbrook Primary School, and I believe probably another school in the MAT. Is that right, Alan? There's at least a couple of...
just one this year.
Just one this year. Okay, just the one. So just very, very quick housekeeping and agenda. This will be 60 minutes. So very rough agenda. I'll start with a few minutes of just introducing Marty the robot. For those of you who don't know who Marty is, Sarah will follow me with a bit of a chat about Strawbees, and then we'll we'll hand it over to Alan for some coding club fun. For people who are not familiar with Marty, Marty is the award-winning walking, talking, dancing coding robot. And Marty helps teach coding, robotics, and STEM in a really fun and hands-on way to students age 4+. I mean, I say 4+, but I know, Alan, that you've used it with students who are 3. So it kind of starts at the very, very basic, from the fundamental and all the way up to real life text-based language Python. And then, just a little bit about a humanoid robot. Effectively, what it means is that Marty, it looks like a human. So it, has arms, legs, a face that emotes, and children very much are traditional in what they think a robot is. And so they view Marty as a quote unquote real robot. Marty also has a bunch of sensors and 9 servos throughout, so you can control each limb, if you will, individually. So that's Marty. And I thought I would just cover very, very quickly some of the newest features that we have brought on board. So one of our most exciting and sought after add-ons was the LED eyes. And so I'm delighted to say that all Martys now come fully equipped with the LED eyes. We've also introduced a way to teach artificial intelligence and machine learning and primary. The different options are endless of what you can teach Marty to do in terms of machine learning. And then finally, we've introduced some improved sound and speech functionality. So we now have text to speech, and we can also translate it, or Marty can translate, in over 40 languages. So that's just kind of what we've introduced recently. And then last slide for me, just to say that Marty really is value for the whole school. So we start in reception and go really all the way to high school and beyond. But these are all the different kind of programming environments that you can use to code Marty, from a very, very basic screen-free or unplugged coding in reception in year 1, through remote control, and then block-based coding that is based on Scratch and Scratch Junior, which should be very familiar to the kids already if they've used Scratch and Scratch Junior. And those are symbol-based and text-based block coding blocks, and they can use them to control Marty. And then later on, when they move on to text-based real-world coding language Python, they can also use that to program Marty. So that's it for me, and I will now hand it over to Sarah.
So I'm Sarah, and I'm from Strawbees. As you probably heard, my fancy job title name is the UK Partnership Manager, which means that I get to bring Strawbees to the UK, which is really exciting. So what is Strawbees? For those of you who don't know, Strawbees is a creative way of learning STEM using hands-on pedagogy. And basically that means it's a hands-on tool that educates learners about building and coding whilst having fun. And you can see in the slide here what we have and what we can create. So we can create things like robots, mechanical scissor linkages, and we can even make things that fly. So what we do is we have a few solutions. This is actually our STEM classroom kit, which is suitable for 30 learners. This is a building solution. So you'd see there, we've got the pipes and we've got the connectors, and that's where the magic begins. We're able to construct many different things and also as well use ideas simulated from Strawbees Classroom, which is our learning platform. Strawbees Classroom, having recently come into the UK, is now aligned with Curriculum for Excellence for Scotland and National Curriculum for England. We also have Pocketful of Ideas, which allows imaginations to start from the very beginning. These come in two forms, and for our older learners as well, we have scenarios, and for our younger learners, we have just some ideas, things like build a hat for a cat and that kind of thing. What's really exciting about Strawbees though is you can make them come to life with microbit, and you know that microbit has become a big thing in the UK recently, especially with the new rollout. And for this, we have another kit size, again for 30 learners, and it comes with microbits as well. And this is something that Alan's going to show us today. And without further ado, I think it's time we get to Alan.
Hello, everybody. Hi. Thank you for signing up and signing into this webinar. To show you are watching live from London, my name is Alan. I am the subject lead for computing at Willowbrook Primary School Academy in East London. I'm just going to turn the camera around. Boys and girls, can you give the camera a wave? Although I've been subject lead for computing since 2020, I've actually been working at this amazing school since 2015 and started running an after-school code.org workshop since 2016 because, as code.org say, I firmly believe that every student in every school should have the opportunity to learn computer science. So my school are very fortunate to have established a fantastic collaboration with Robotical and Strawbees to enable the children to practice and apply their coding skills with world-class resources. For those watching from UK primary schools in the UK, this is the final call to register for your free class set of 30 microbits. Every pack also has details of a monthly prize draw thanks to friends at Nominate. So for today's live coding challenge in a few minutes time, we're going to be working on two projects. The first is going to be using microbits as a controller to make or build Strawbees robotics boards into a real world pedestrian light system. The other is going to be a very simple way of making a set of festively decorative lights. And we've got children here to do that with us. So before we do, I wanted to say a very special thank you again to our friends Nat at Robotical, who I actually only first met in 2021 when I saw an advertisement promoting their 2-week loan available from Robotical. I was so enthralled by Marty's versatility at teaching parts of the primary curriculum connected to physical computing that I mapped out the statutory statements that you can see on this slide and immediately put Marty to use in all the classes I regularly teach, to the point that at Willowbrook, we have introduced these principles of computational thinking, as shown on this slide, computational thinking slide. Thank you. And computer programming to children, as Nat mentioned earlier, as young as age 3. Marty has become more well known to the children at school more than me. You can read more about the impact that Marty has had on teaching and learning at the amazing school I am so pleased and proud to be to work for in this article I wrote for the Association of Science Education Journal, which I also shared at the Playground to Poster presentation at ISTE in June this year, where I got to meet and make so many incredible connections. So a special hello to Head of North America Operations, Hal, who's probably just woken up, and the most incredible teacher I've ever met, Miss Shields from Dallas. As I was telling all who came to speak to me at the ISTE booth, there are a number of key features which makes Marty well worth the investment for schools. Firstly is the fact that for schools like those in England who are expected to focus on a knowledge-rich curriculum, teachers can introduce Marty by focusing on its structure and design. I will, for example, talk to the youngest learners about what the differences are between Marty and the devices that they may be familiar with. The fact that Marty has a programmable brain which controls the motors to enable it to move, which makes Marty different from the digital devices available in school and at home. It was interesting too, when teaching about the chronology of digital technology, that historians can trace the origins of robots back to the time of ancient civilizations and way before the first computers. Some historians would say that the first use of the word robot was only in the 1920s, and it was in 1938 that the first TV program had robots in their story. Doctor Who fans may or will know that the Daleks first featured in 1963. So learning about how Marty operates has also enabled the children to think like engineers working in the real world. In a previous hour of Code Club meeting, the children were trying to work out how to control Marty by traveling the length of the classroom corridor using its foot-mounted color sensor. By creating a track of colored paper that Marty can follow, made the children recognize the potential application of an automated system for moving parcels and ultimately people. The ability to code Marty online via a web-based interface has been the biggest game changer to making the device accessible to all schools. As schools need to increase their vigilance to cybersecurity, means that the ability to install product-specific apps is increasingly difficult. The web-based version easily enables the children to emulate working in NASA Space Command. While we're just moving on to the live coding arrangement, this is just a recap of where the parts of the national curriculum for schools in England the children have achieved by doing all of what we've described so far. So the boys and girls in the room, please say hello again. Hi. Can you also please say hello if you have a Strawbees robotics board connected to a microbit? Hello. You got, okay. Put your hands up as well so I can see. Who's got a Strawbees robotics board? Okay. So what we're going to do now is we are going to switch over to the microbit.org website. So can the boys and girls in the room please join me? I'm going to ask if you could be helping from the board. So hopefully those joining us on the webinar are able to see the microbit website. So boys and girls, can you also be on the microbit website? And then can you please do what we've just shown you? So click on Let's Code and click on Make Code Editor, please. Let's Code and Make Code Editor. The amazing thing about the boys and girls in code.org is that they work together as a fantastic team. So this first project we're going to do is quite a long one, but the boys and girls here are used to coding quite a few blocks of codes together. So can everybody please open a brand new project? Okay, and let's call this traffic lights or pedestrian lights. If you don't know how to spell pedestrian lights, it doesn't matter. Whatever name you like to call it, just call it traffic lights or pedestrian lights. I'm going to call it pedestrian lights and then click on create. Right. So what we're going to do today is we're going to make a set of lights, a bit like the crossing outside our school. So outside our school, we have got a set of lights which the children can control to get across the main street. Okay. And they're called pedestrian lights because we as pedestrians can control them. So we're going to create the microbit so that you can actually press a button A or button B, to control the lights, and the lights, the LEDs on the Strawbees will become the traffic lights. Okay, so this is what we're going to do. Before we create anything, we need to load the Strawbees extension. So can you first scroll down to where the word extensions is, and then can you type in the word Strawbees, STRAWBEES? You will see you've got a link for robotics inventions. And then when you click on that link, if you click on that link, it will load some brand new blocks for you. Okay? It will load some brand new blocks for you. Okay? So can you now see you've now got a brand new menu with a letter S in a circle? Boys and girls in the room, can you give me a thumbs up if you see the letter S in the circle? Brilliant. So what we're going to do is we're going to just make sure that we've got a variable called position. Okay? So we need to make a variable. So we click on variables, make a variable, and type the word position. And we also want to make a variable called movement. Give me a thumbs up when you've been able to do that. Well done. Thank you. Thank you. All right. And then what we're going to do, we're going to start by setting up our program. We need to be able to connect the microbit to the Strawbees robotics board. And this is how we do it. We need to go back to variables, the variables block. And when you go to the variables block, can you see that you've got a block that says set? My one says set movement. It might say set position at the moment. Okay, so if you just pull the set block, and can you put that into your start block, just like that? Thank you. Brilliant. It is meant to be set position. So can you pull down the menu to show position? Okay, so it should be set position. And in our forever block, let's go to the Strawbees menu option. And the Strawbees menu option, can you see that there is a block, scroll down, that says set servo? Can you see, if you scroll all the way down to the bottom, set servo A. Brilliant. Okay, now we don't want servo position to anything. We want the servo position to be the variable position. Okay, so go back to your variables and then get the set servo block first. And then what we're going to do is we're going to get another forever block. Get another forever block. So from the blue basic blocks, pull out a forever block, and inside this forever block, we're going to use the variables block, and this time we're going to use the set movement block, and it will be movement this time. And this time we want to use the accelerometer function. The accelerometer function. The accelerometer is the shaky part that works on the microbit. Okay. So I'll show you where. We go to input. And can you see on the input? Originally, we were just focusing on the buttons. Yeah. So if you scroll down on the inputs, you'll see there is a round one called acceleration. Yeah, acceleration MG. Okay, acceleration MG, and just leave it as X. You don't need to worry about that at all. And then underneath that, we're going to choose another variables block. And this time, actually, we need to make a variable. We need to make the variable called hue. So make a variable. Make a variable. And it's HUE. Hue is another word for shades of color. We also have from in one of the other classrooms a design and technology club where they've been using the Strawbees. So can you come bring your Strawbees models forward, and you can see these were just made in the last half hour while we've been live. So what have you guys been making?
That's amazing.
Brilliant. And what's this you've made?
I don't really know what it is,
but he's just being creative. It looks like
wow.
It looks like a system for an orb. It could be a raft. It could work as a raft, or it could work as a musical instrument. And we're going to be building musical instruments in the summer term. So thank you very much, guys. So we've just dropped this block here, this set hue to 0 block, from the variables block into the forever block. Okay, with this acceleration mg, exactly as shown on the board. Now, if you go to the math block, you've got a block that says map. There's lots of numbers there. If you scroll right to the bottom of the math block, you've got a block that says math. Okay? Math, M-A-T-H. I know it's really annoying. We're British. We love math. Sorry to our friends across the pond who prefer math, the singular. What the boys and girls in the room are doing is they're going to be using variables now. We've been using variables all along, but we're going to be really using our variable knowledge now as well. So we've got a block that reads set hue to map. We're going to replace the first number with the variable movement. Movement. Now, the low should be minus 1023. And the high can stay as 1023. And the low is 0. And the last high needs to be 100. Okay. So what we're doing is the boys and girls in the room have heard before. I'm their regular teacher as well as running this club for them. So the children will have heard us talk before in a previous lesson about how. Can anybody shout out how many millions of colours can we see? Can a computer make? Can anybody remember? It's a 2-digit number, less than 20, but more than 10. Can you remember? Not quite 15, 16 million colours. Okay, 16 million colours. And so we're trying to use our programming knowledge to control the shade of colour that will show on 16 million colours. Just over 16 million colours. Well done, well remembered. Okay, so now let's code one of the buttons then. Let's code one of the buttons. It doesn't matter whether you choose to code button A or button B. I'm going to choose button A. We want the change position variable. So go back to variables. So change, and can you make it change position? Instead of hue or movement, can you make it change position? And it should be by -10. And then we go to the Strawbees blocks, and we're going to choose set A, sorry, set RGB LED A to, and we want to set it to green. Set it to green. And we also want the same again, but this time make LED B to green. We're going to use a if loop to create a timer.
There is no if loop on loop.
Okay, so go to loop. Sorry, not loops. Logic. Well done. Logic. If true. Okay, so then what we're going to do, so we're going to go to our logic block now. Let's choose the second one. Let's choose the second one, which says less than with the arrow. Okay, and drop that into the true function. Look, we're comparing this variable, this value, with the variable position. Okay, so just pull the name of the variable into where the first 0 is. So it should look like that. Then set position to 0. Set position to 0. All right. Now, we won't need to code all of that again. What we can do, and I'm sure the boys and girls will remember, we've done this duplication function before. Just click on duplicate. And when you've duplicated it, we're going to change it over so that the new duplicate block is to activate button B. And then we want the LED A, instead of going green, we want it to go red. And we want both LEDs to go red. And if position should change, instead of saying if position is less than 0, can you make that 70, please?
Can I ask why 70, Alan?
It's to adjust the timing. Because we've only got 10 minutes left and we want to give the people who are watching around the world a chance to ask questions about what we've done. Should we just go straight to the really easy Christmas project? Yeah, let's go straight to the really easy Christmas project. So let's go back to, if you click on the microbit logo and just call it lights. Call it lights. You can call it Christmas lights if you want. And this is a really easy project. It only has 4 blocks of code. 4 blocks of code, and we're going to be using random values. We are going to be using, though, the Strawbees extension blocks. Go to forever, bring down your forever block. Strawbees, set RGB LED to red, green, and blue. Instead of red, green, and blue being numbers, we can use our, boys and girls, we can use variable. Instead of using variables, we can use our maths function to choose a what number? What kind of number? Random number. Brilliant. Random number. So go to math and then pick random. And because we are talking percentages, we can go random 1 to 100. Yeah. And just repeat that process for the other 2 variables. So red, green, and blue. Pick random 1 to 100. Yep, that's it. Pick random 1 to 100. And when you've done that, do that again. Duplicate and go to B. And then when you load it up to your Strawbees, you know how to load it up? Download to your microbit, put your microbit into your Strawbees, turn your Strawbees on, and you'll have a brilliant set of Christmas light decorations for your Christmas tree. And that's our kind of hour of code.
Amazing.
Over to Nat.
Thank you. Alan, we do have one question for you.
Okay.
I'm going to pull it up on the screen very, very quickly. I don't know if you can answer it. Hopefully you can. Paul is asking, can introductory AI machine learning coding be utilized with the microbit platform? If so, for what ages and how comprehensive could it be?
We have a hello from the boys and girls who have done a bit of AI and machine learning in club. Yeah, so we did this a few weeks ago where we were trying to build our own database where we were linking some AI and machine learning to a scratch animation, which would turn on a fan, turn on and off a fan, and turn on and off a light.
Oh,
yeah,
that's amazing. And what age and stage was that for?
We're talking about children who are from about the age of 10.
Okay. Yeah, that's kind of what I put down for us as well. So if you are interested in having a trial of Marty the Robot, we do free trials to schools, and you can have a go at trying the AI machine learning functionality. And we say year 5, but obviously in some schools it could be earlier. Jane, Peter, Sarah, have we got any other questions in the chat? No, it looks like everything else has been answered. Okay. So that's exactly 1 hour on the dot, 1 hour of code. And thank you so much for joining us. Um, and have a lovely evening.
Okay. Thank you.
Thanks, everyone. Bye.
Bye.